Welcome to One Chemistry. In this video, we are going to see Wade's rule. We will understand it through basics and 51 fully solved examples. We are applying Wade's rule for boranes, heteroboranes, carboranes, and Zintl salts. It will be very interesting. Stay tuned. What is inside this video? First, we will see library of boranes. It will help you to solve the problem as well as it will be a reference for you. Then we will see Wade's rule. What is Wade's rule? Formula behind it. Boranes, heteroboranes and Zintl salts. The most important thing you should know here is we are going to solve 51 examples. Those are all fully solved and taken from various examinations. Here the library of Borane is given. It is for your quick reference. Mostly three types are well known. Even though there are many, three are well known and common. Those are Closo, Nido and Arachno. We will see detailedly later. This is for your reference and problem solving. Second library we are seeing here is heteroboranes. Heteroborane means borane with heteroatom, carbon, phosphorus, germanium, nitrogen, tellurium, sulfur, so on and so forth. So this also will help you to solve problem by yourself. So make use of it. Then the quick reference is Zintl salts. Those are all isoelectronic with boranes but metal clusters. We will solve 20 clusters: tin, bismuth, germanium, indium, tellurium, antimony, arsenic, so on and so forth. So make use of it. Solve problems by yourself. The first section we will see here is Wade's rule and basics behind it. What is Wade's rule? Why we are studying Wade's rule? That is, we are identifying structure from the formula. It is very important. We are not using any instruments, any chemicals. Without that, we are getting structure just by formula and few calculation. That's why it got famous. So Wade's rule help you to find the structure. Then next is where you can apply those rules. First we will see boranes. Boranes are boron and hydrogen compound. This is also a cluster. These are all basic compounds for the Wade's rule. Next, heteroboranes. Mostly they are isoelectronic with borane. There also Wade's rule will be applied. Then Zintl salts. Zintl salts metal clusters. That's also will come as the isoelectronic species with borane but with metals. Then boranes with charge. Charge is basically removing or adding hydrogen. There also Wade's rule will be applied. Then borane as a salt, that is charged boranes balanced with metal ion. So metal salts of boranes. So 5 categories you can apply the Wade's rule and find the structure. Then Wade's rule and Wade-Mingo rule. Wade's rule basically for boranes, Zintl salts and heteroboranes. Wade-Mingo is for metal salts, basically a complex compound or organometallic compounds. Example, osmium carbonyls. So don't confuse with Wade and Wade-Mingo's rule. Here we are going to discuss only Wade's rule. What is the theory behind the Wade's rule? That is skeletal electron pairs theory, SEP theory. Why you have new theory? Because you have many bond types. Why we are using special theory here? Normally the bonds are 2 center 2 electron bond like hydrogen. Use 2 electron 2 hydrogen form a bond. Here boranes are unique. It has 3 center 2 electron bond. It is like borane, borane, hydrogen. All three use 2 electrons, so bond is specific. That's why we use special theory. Here we don't use SCP theory. Instead, we use simple formula. to find the structure. Let us see the basic shapes because basic shapes the cluster forms. Here vertices as n4 mean tetrahedron, n5 mean trigonal bipyramidal, n6 mean octahedron, n7 mean pentagonal bipyramidal, n8 mean dodecahedron, n9 mean tricapped trigonal prism, n10 mean bicapped square prism, n11 mean octadecahedron, n12 mean icosahedron. Those are all common shapes. Different variations are possible, but you should know the basics behind it. Here, boranes classified into Closo, Nido, and Arachno. Closo means the structure is closed one, like cage. Nido means you remove only one atom here, that is one vertex is missing, that is called Nido. If you remove two, it becomes Arachno. So closed mean Closo, one atom missed mean Nido, two atom missed mean Arachno. So you should know the basics here. Why we call Closo, Nido, Arachno. Closo means closed, Nido means nest-like structure, Arachno means spider-like structure. These are all the basics. You should know why we are calling the name and what is the difference behind that. Then we will see all the basic structure. Those are Closo, Nido, Arachno, Hypho, Clado, Supercloso and Hypercloso. What is the difference here? The difference is N plus M. N is boron, M is excess of hydrogen. If N plus 2 mean Closo, N plus 4 mean Nido, N plus 6 mean Arachno, N plus 8 mean Hypho, N plus 10 mean Clado, N plus 0 that is N supercloso, N minus 2 hypercloso. Memorize this, otherwise you cannot solve the problems. You should know the basic difference between structure and type. Structure mean octahedron, type mean Wade's type. Wade's type and structure both are different. Don't get confused. Here I given P6H6 2 minus. Structure is octahedron, but Wade type is Closo. Structure is stable or vertices are stable. By removing borane, here you will get Closo, Nido and Arachno and many more types. Here Wade type can be in any structure, tetrahedral, octahedral and many more. So don't get confused between structure and Wade types. Then heteroboranes, borane with heteroatom. Here I given C2B4H6. It's a heteroborane with carbon. How you solve it mean? You add boron equivalent for the heteroatom. Here carbon. Carbon you can write it as boron plus hydrogen, kind of isoelectronic. If you write it, you get borane. Then apply the normal rule. The heteroatom can be from any group, boron group or carbon group or nitrogen group or oxygen group. Mostly p block elements you should memorize, otherwise you miss the calculation. Then the Zintl salts. What is special about it? It is like heteroborane but with metal cluster. Here tin 4 2 minus is given. Tin valency is 4, which is the equivalent of boron plus hydrogen. Why? Boron valency is 3, hydrogen is 1. That's why it equals tin. So if you substitute it, you have boron equivalent. Then apply the Wade's rule. Here metal clusters also can be come from any group, boron group, carbon group, nitrogen group and oxygen group. So you should know all the p block elements to solve the Zintl salts. Here the most important thing, how you find the structure, the step-by-step procedure. First you should write boron equivalent or compound, then count the borane. We should write as N, Then count the hydrogen, it is H. If charge is there, it is C. Then find the excess hydrogen, which is M. So M equals H minus C minus N. Then predict n plus m. N plus 2 mean Closo. N plus 4 mean Nido. N plus 6 mean Arachno. N plus 8 mean Hypho. N plus 10 mean Clado. N plus 0 mean Super Closo. N minus 2 mean Hyper Closo. So you can find the structure. For that you should memorize boron equivalent also. Carbon group mean BH. Nitrogen group mean BH2, oxygen group mean BH3. Here I give an example B6H6 2 minus. Here boranes are 6, so N equals 6. Hydrogens are 6, so H equals 6. The charge is minus 2. If you substitute in the formula, H plus C minus N mean 6 minus of minus 2 minus 6, which gives M equals 2. N plus M, which is N plus 2 structure, which is Closo. So in this way you can find the structure of the compounds. Then you should know what are all the mistakes you may commit. While you solve the problem, you should remember the fact that M should not be the odd number. If it is the odd number, you commit a mistake either by adding or removing the charge or counting the borons or hydrogen. Here I given C2B4H7 minus carbon equivalent is BH. If you substitute it, you should have N is 6, hydrogen is 9. Charge I written mistakenly as 0 mean you end up with M equals 1. Definitely a mistake because it should be even, not a odd number. So you should know the fact that M must be always even number. Then most important mistake is salt versus heteroatom. Here I given Na2 B10H10. Here Na2 plus you should not think as heteroatom. It is a balancing charge or a counter ion. So you should not include in the calculation. Na plus B10H10 equivalent to B10H10 2 minus with Na2 plus. If you apply that, N is 10, hydrogen is 10, charge is minus 2 mean H minus C minus N gives M equals 2. M equals 2 mean Closo structure. So you should know the fact here is salt provide charges. You should not count it as heteroatom. Then we are moving into the important session, solved examples. We are going to solve 51 examples. Why so many? Because problems are best way to learn. It will give different perspective and complete understanding. Let us see the first example. Here B5H5 4 minus is given. You have to find the structure using Wade's rule. We will go by the basics. It is a simple borane, so we will go with step by step. First we count number of borane, which is 5, so N equals 5. Then number of hydrogen, which is H, that is 5. Then charges C, which is minus 4. Then excess of hydrogen using H minus C minus N. So excess of hydrogen M equals 5 minus of minus 4 minus 5 gives 4. So M is 4. So N plus M, which is N plus 4. N plus 4 mean according to our table it is a Nido structure. The concept you have to learn here is charges are important part of the borane. Always careful with that. Then the next example, you have to find the structure of Tl to Te2, thallium and tellurium with charges. You should find the structure using Wade's rule. Here there is no carbon, no borane. Technically it's a Zintl salt. It's a metal cluster with two metals. Whenever metals given, you should write boron equivalent. Thallium equal to boron. Why? Because it is in the boron group. Tellurium equal to BH3 because it is in the oxygen group. So thallium equals boron. Tellurium equals BH3. So we rewrite with the boron equivalent. Thallium we should write boron. Tellurium with BH3 mean totally B4H6 2 minus. It become normal borane. We will apply our rules. Here borane is 4, that is N equals 4. Hydrogens are 6, so H equals 6. Charge is minus 2. So if you find excess of hydrogen, which is M, H minus C minus N, H is 6, C is minus 2, N is 4. If you substitute in the formula, you find M equals 4. So M4 mean N plus 4 system. N plus 4 mean it is Nido structure. The concept you have to learn here is in Zintl salt, always you should write boron equivalent. Then the next example, here C2B3H5 is given. It is a heteroborane. You have to find the structure using Wade's rule. Here the compound is heteroborane. It is a carborane system. Carbon equals pH. So we rewrite the structure with BH. You should write BH instead of carbon. If you substitute it, you end up with B5H7. The compound is simple borane now. We will go by the formula. Borane is 5, so N equals 5. Hydrogen is 7, so H is 7. Number of charges, the compound don't have any charges, so C is 0. Excess of hydrogen is M. That is what we have to find. M is H minus C minus N. H is 7. Charge is 0. N is 5. If you substitute it, you can find M equals 2. M equals 2 mean it's the Closo system. So C2B3H5 has Closo structure. The concept you have to learn here is carboranes are common. In that system, for carbon, you should write BH as boron equivalent. Then the next example, B7H9. You have to find the structure using Wade's rule. Here the compound is borane, B7H9, simple system. Answer is straightforward. Just find M. We start with boron. Number of borons are 7, so N is 7. Number of hydrogens are 9, so H is 9. There is no charges, so C equals 0. So excess of hydrogen, which is M, equals H minus C minus N. H is 9, C is 0. N is 7 mean M equals 2. N plus M, N plus 2 mean it is a Closo system. So B7H9 has Closo structure. So according to the Wade's rule, B7H9 has Closo structure. Then the next example, here Me3Si twice, B10H10 is given. It is the heteroborane with silicon. You should find the structure using Wade's rule. According to the Wade's rule, you should write boron equivalents for heteroborane. Here silicon with trimethyl is given, which is silicon. Boron equivalent for silicon is BH. So we substitute BH for Si. Methyl given for valency. We don't consider methyl. For silicon we write BH. So the compound is BH2 B10H10. If you write clearly, it is B12H14. So we go by basics now. We should find number of boron, which is N, that is equal to 12. Hydrogens are 14, so H is 14. The charges are 0, so C is 0. To find the structure, you should find excess of hydrogen, which is M equals H minus C minus N. H is 14, C is 0, N is 12. So excess of hydrogen M gives 2. It is a N plus 2 system. If you look at the table, N plus 2 is Closo structure. So according to the Wade's rule, Me3Si twice B10H12 has Closo structure. Then the next example, here you have B5H11. You should find the structure using Wade's rule. It is a simple borane compound with borane and hydrogen. So straightforward, we will find the excess of hydrogen. Number of borane is 5, so N is 5. Number of hydrogen is 11, so H is 11. Charge is 0, so C is 0. Excess of hydrogen M, which equals H minus C minus N. H is 11, charge is 0, N is 5. If you calculate it, you will get M equals 6. According to the table, if you have N plus 6 system mean Arachno structure. So the compound B5H11 has Arachno structure. Then the next example, here you have tellurium B9H11. You should find the structure using Wade's rule. Here the given compound is heteroborane. Heteroatom is tellurium. So we should find boron equivalent. Tellurium is in oxygen group. So boron equivalent is BH3. So if you redraw the structure with borane, for tellurium you should write BH3. So BH3 B9H11. If you write combining way, B10H14, the compound become borane. So we apply normal rules. Number of borons are 10, so N equals 10. Number of hydrogens are 14, so H is 14. Charges are 0, so C equals 0. Excess of hydrogen formula is M equals H minus C minus N. Hydrogen is 14, charge is 0, N is 10. So excess of hydrogen M equals 4. So N plus 4 system, which is the Nido system. So according to the Wade's rule, TeB9H11 has Nido structure. Then the next example, here B3H5 is given. You should find the structure using Wade's rule. Here the given compound is B3H5, simple borane. We will go by the basics. Here number of borane is 3, so N equals 3. Number of hydrogen is 5, so H is 5. Charge is 0, so C is 0. Excess of hydrogen, which is H minus C minus N. H is 5. Charge is 0, N is 3. If you substitute it, you have M equals 2. It is a N plus 2 system. According to the table, N plus 2 means it has Closo structure. So according to the Wade's rule, B3H5 has Closo structure. Then the next example, here you have Na2B10H10. We should find structure of the compound with Wade's rule. Here Na2B10H10 is given. Na2, you should be careful with that because Na is not a heteroatom. It is a counter ion. So we write as a charges B10H10 2 minus and Na plus. So Na plus is counter ion. So we should only consider B10H10 2 minus. So it is a simple boron. We will apply the normal rule. Here number of boranes are 10, so N equals 10. Number of hydrogen is 10, so H is 10. Charge is minus 2, so C is minus 2. Excess of hydrogen formula is H minus C minus N. So H is 10, C is minus 2, N is 10. If you substitute in the formula, you have M equals 2. According to the table, M is 2 mean N plus 2 system, which is Closo system. So the structure of Na2B10H10 is Closo structure. The concept we have to learn here is during the Wade's rule calculation, careful with the salts. Salts counterions are not heteroatom. Then the next example, here you have B8H14. You should find the structure of the compound using Wade's rule. Here B8H14 is given. It is a simple borane. So answer is straightforward. Find the excess of hydrogen. Excess of hydrogen. We should find number of borane, which is N, which is equals 8. Then number of hydrogen, which is 14. So H is 14. Then the charges. There is no charge. So C equals 0. So excess of hydrogen, which is M, H minus C minus N. H is 14. C is 0. N is 8. If you substitute in the formula, you can see M is 6. M is 6 mean according to the table N plus 6 system, it is Arachno structure. According to the Wade's rule, B8H14 has Arachno structure. Then the next example, here you have B5H5 anion 2 minus system. You should find the structure using the Wade's rule. Here you have simple borane but with charges. Charge is outside the sphere, don't confuse. It's a simple charge 2 minus. So we go by the basic to find the excess of hydrogen. Here number of boranes are 5. So N equals 5. Hydrogens are 5. H is 5. Charges are minus 2. That is sphere charges. C equals minus 2. Here M is H minus C minus N. H is 5. C is minus 2. N is 5. If you substitute it, you have 2. It is a N plus 2 system. According to the table, it is Closo structure. So according to the Wade's rule, B5H5 2 minus has Closo structure. Then the next example, here you have TeB9H11 tellurium in the boranes. You should find the structure using Wade's rule. Here the compound is borane with tellurium. It is a heteroborane system. So we should write tellurium equivalent. Tellurium is in the oxygen group. So boron equivalent is BH3. So in the structure, you should write BH3 instead of tellurium. If you write it, you have B10H14 system. The compound becomes simple borane. We will go by the basics. Find the excess hydrogen. Here number of boranes are 10, which is N equals 10. Number of hydrogens are 14, which is H equals 14. Number of charges are 0. For the excess hydrogen, formula is M equals H minus C minus N. H is 14, C is 0 because there is no charges. N equals 10. If you substitute in the formula, you have M equals 4. M equals 4 means it is a N plus 4 system. According to the table, you have Nido structure. So the compound TeB9H11 has Nido structure. Then the next example, here B5H9 is given. You should find the structure using Wade's rule. Here you have B5H9. It is a simple borane. So straightforward, we can find the excess of hydrogen, which is H minus C minus N. Here N is number of borons, which is 5. Hydrogens are 9, so H is 9. No charges, so C is 0. If you substitute in the formula, H minus C minus N, 9 minus 0 minus 5. which gives M equals 4. M4 means N plus 4 system. From the table, you can clearly see it has Nido structure. According to the Wade's rule, B5H9 has Nido structure. Then the next example, here you have T6 2 plus tellurium cluster. You should find the structure using Wade's rule. Here tellurium is Zintl salt, so we should write the equivalent. Tellurium equals pH3. Why? Because it is in oxygen group. Oxygen is the equivalent of 1 boron, 3 hydrogen. So the tellurium is pH3. Instead of tellurium, we should write BH3. So BH3 6 times 2 plus. So if you find exact equivalent of borane mean B6H8 2 plus. Now it is become borane. We will find excess of hydrogen. For that, first step will be counting the number of boron, which is N, which is equal 6. Then counting the number of hydrogen, which is 18. So H is 18. Then the charges. Charge is plus 2. C is plus 2. Our aim is to find excess of hydrogen, which is M equals H minus C minus N. That is 18 minus of plus 2 and minus 6. If you solve it, you get M equal 10. So it is a N plus 10 system. According to the Wade's rule, Te6 2 plus has clado structure. Then the next example, here you have simple borane B10H14. You should find the structure using Wade's rule. So B10H14, it is a simple borane system. So we will find excess of hydrogen and apply to Wade's rule. First step will be identifying number of boron, which is 10. So N equals 10. Number of hydrogens are 14. So H equals 14. The charges are not there. So C is 0. Excess of hydrogen formula is M equals H minus C minus N. If you substitute the value, it will give 14 minus 10, which equals 4. So it is a N plus 4 system. If you look at the table, it has Nido structure. According to the Wade's rule, B10H14 has Nido structure. Then the next example, here C2B7H11 is given. You should find the structure of the molecule using the Wade's rule. The given compound is C2B7H11. It is the heteroborane, carborane. You should find boron equivalent. Carbon is first compound in carbon series. Boron equivalent will be BH, 3 plus 1 system. So BH. If you write boron equivalent, for C you have to write BH. So BH twice B7H11 mean it is B9H13. It becomes simple boron. So we find excess of hydrogen. First step will be identifying number of boron, which is N equals 9. Then hydrogen, which is 13. So H is 13. There is no charges. So C is 0. The excess of hydrogen formula is M equals H minus C minus N. If you substitute the values, it is 13 minus 9 gives 4. So it is N plus 4 system. If you look at the table, it is the Nido system. So according to the Wade's rule, C2B7H11 has Nido structure. Then the next example, here you have C2B9H12 minus. You should find the structure using Wade's rule. The compound is heteroborane with carbon, technically a carborane with charges. So we should write boron equivalent. Carbon is the first atom in carbon series. So C is BH. It is a 3 plus 1 system. So we write BH. If you write equivalent in the formula, BH twice, B9, H12 minus. After writing boron equivalent, it become B11, H14 minus. So the compound become normal borane. We will find excess of hydrogen, which is H minus C minus N. So number of borane is N here, which is 11. Number of hydrogen is H here, which is 14. The charge is minus 1 here, so C is minus 1. If you substitute in the formula H minus C minus N, 14 minus of minus 1 minus 11, which gives 4. So it is a n plus 4 system. If you look at the table, it is the Nido structure. So according to the Wade's rule, C2B9H12 minus has Nido structure. Then the next example, here you have B11H15. You should find the structure of the molecule using Wade's rule. B11H15 is the simple borane. So straightforward, we will find excess of hydrogen. For that, first step will be identifying number of boron, which is N equals 11. Then hydrogen, which is H equals 15. Then charges. Since there is no charges, C equals 0. Excess of hydrogen will be M, that equals to H minus C minus N. If you substitute the values, it is 15 minus 0 minus 11. So M is 4. It is a N plus 4 system. If you look at the table, N plus 4 mean Nido structure. So according to the Wade's rule, B11H15 has Nido structure. Then the next example, here Bi5 3 plus is given. You should find the structure using Wade's rule. Here only bismuth metal is there. Technically it is a Zintl salt, so it is a hetero system. We should write bismuth equivalent. Bismuth is in nitrogen series. It is the BH2 system. So for bismuth we should write BH2. So if you substitute in the formula for Bi BH2, you have BH2 5 times 3 plus, which equals B5H10 3 plus. The compound becomes simple borane. So we will find excess of hydrogen. So the first step will be finding the number of borane, which is N equals 5. Then finding the hydrogen, which is 10. So H is 10. Charge is plus 3. So C is 3. The excess of hydrogen formula is M equals H minus C minus N, which is 10 minus 3 minus 5 gives 2. It is a N plus 2 system. If you look at the table, N plus 2 means Closo. So according to the Wade's rule, Bi5 3 plus has Closo structure. Then the next example, you should find the structure of C4B2H6. You should use Wade's rule to identify the structure. The given compound is C4B2H6. It is the heteroborane. Only carbon is there, so it is a carborane. We should write boron equivalent. Carbon is 3 plus 1 system, so the equivalent is BH. So for the carbon, we have to substitute BH in the formula. So BH 4 times B2H6, which equals B6H10. Then the compound becomes simple borane. We will find excess of hydrogen. The first step will be identifying the boron, which is 6. So N equals 6. Then hydrogen, which is 10. So H equals 10. There is no charges. So charge is 0. The excess of hydrogen formula is M equals H minus C minus N, which is 10 minus 0 minus 6 gives 4. So it is a N plus 4 system. If you look at the table, it has Nido structure. According to the Wade's rule, C4B2H6 has Nido structure. Then the next example, Here you have CpB10H11. You should find the structure using Wade's rule. The given compound is CpB10H11. It has two heteroatoms, carbon and phosphorus. That's why this problem is different and unique. So we should write boron equivalent. Carbon boron equivalent will be BH. Phosphorus will be BH2. Phosphorus in nitrogen group. It is 5. So 3 plus 2 system. That's why BH2. So if you substitute the boron equivalent, it will be BH, BH2, B10, H11. If you write combined way, it is B12, H14 system. So it becomes simple borane. We will find excess of hydrogen here. First step will be finding the number of boranes. Number of boranes are 12. So N is 12. Number of hydrogens are 14. So H is 14. Charges are not there. So C equals 0. Excess of hydrogen formula will be M equals H minus C minus N, which is 14 minus 12, which gives 2. So it is a N plus 2 system. According to the table, if you look at it, it is Closo structure. So according to the Wade's rule, CpB10H11 has Closo structure. Then the next example, here S4 2 plus is given. You should find the structure of the molecule using the Wade's rule. Here only single atom is given, which is heteroatom, cluster of 4. So technically it is a Zintl salt. To find the structure, we should write boron equivalent. Sulfur is in the oxygen group, so sulfur equivalent will be BH3. If you write equivalent with the structure, BH3 4 times dication. If you expand it, it will be B4H12 2 plus. The compound becomes simple borane. We will find excess of hydrogen. Identifying the boron will be first step. Borons are 4, so N equals 4. Hydrogens are 12, so H is 12. Charges are plus 2, so C is plus 2. Excess of hydrogen formula is M equals H minus C minus N, which gives 12 minus 2 minus 4, which gives M equals 6. So it is a N plus 6 system. If you look at the table, N plus 6 means Arachno structure. According to the Wade's rule, S4 2 plus has Arachno structure. Then the next example, here C2B7H13 is given. By using Wade's rule, you should find structure of the molecule. Here the given compound is C2B7H13. Here carbon heteroatom is there. It is technically heteroborane, more specifically carboranes. So we should write boron equivalent, which is BH. Carbon is 3 plus 1 system. That's why BH. For the boron equivalent, you should substitute BH for C. So it will be BH twice B7H13. If you write the expanded way, it will be B9H15. Then the compound becomes simple borane. We should find excess of hydrogen. First step will be finding the number of boron, which is N equals 9. Then the hydrogen, H equals 15. Then charges are 0. The excess of hydrogen formula will be H minus C minus N, which is 15 minus 0 minus 9 gives 6. So it is a N plus 6 system. If you look at the table, N plus 6 means it has Arachno structure. So according to the Wade's rule, heteroborane C2B7H13 has Arachno structure. Then the next example, here CpB8Ga2H11, there are many heteroatoms. You should find the structure using Wade's rule. Here CpB8Ga2H11 is given. Many heteroatom carbon, phosphorus, gallium. You should write boron equivalent for carbon BH, for phosphorus BH2, gallium, boron. If you substitute in the real formula, it will be BH, BH2, B8, B2, H11. If you rewrite, you have B12H14. The compound becomes simple boron. So we should find excess of hydrogen to find the structure. First step will be identifying the number of boron, which is 12, that is N equals 12, then hydrogen, which is 14. So H equals 14. There is no charges. So C equals 0. Excess of hydrogen will be M, which equals H minus C minus N. If you substitute the values, it will be 14 minus 12, which is M equals 12. So it is a N plus 2 system. If you look at the table, it will be a Closo structure. So according to the Wade's rule, CpB8Ga2H11 has Closo structure. The concept you have to learn here is don't get confused by heteroatoms. Just follow the basics. Identify the structure. Then the next example. Here you have C2B4H8. You should find the structure of the molecule using Wade's rule. Here C2B4H8 is given, which is the heteroborane with carbon. So it is a carborane. We should write boron equivalent to find the final structure. The boron equivalent of carbon is pH. If you substitute in the formula, you have BH2B4H8, which gives B6H10. The compound becomes simple borane. We will find excess of hydrogen. First step will be finding the borons. Number of borons are 6, so N equals 6. Hydrogens are 10, so H equals 10. There is no charges, so C equals 0. So the excess of hydrogen will be H minus C minus N. If you substitute the values, it is 10 minus 6, which gives 4. So it is a N plus 4 system. If you look at the table, N plus 4 mean Nido structure. So according to the Wade's rule, C2B4H8 has the Nido structure. Then the next example. Here you have germanium C2B9H11. You should find structure of the molecule using Wade's rule. The given compound is GeC2B9H11 with two heteroatom, germanium and carbon. Both are in carbon series. Equivalent will be BH. So for carbon, you should write BH. For germanium, you should also write BH. If you substitute in the formula, it becomes BH, BH twice, B9H11. If you redraw it, it becomes B2H14. The compound becomes simple borane. So we will find excess of hydrogen. First step will be number of boron, which is N, that equals 2. Then number of hydrogen, which is 14. So H equals 14. There are no charges. So C is 0. Excess of hydrogen formula will be H minus C minus N. If you substitute the values, it becomes 14 minus 12 gives 2. M is 2 mean it is a N plus 2 system. If you look at the table, it has Closo structure. So according to the Wade's rule, the compound GeC2B9H11 has Closo structure. Then the next example. Here you have C3B3H7. You should find the structure of the molecule using Wade's rule. Here borane with heteroatom carbon is given. It is a heteroborane more specifically carborane. So we should write carbon equivalent. Carbon is 3 plus 1 system. So boron equivalent will be BH. So we should write BH instead of carbon. So the formula will be BH3 B3H7. If you rewrite, you can see it is B6H10. It becomes simple borane. So we should find excess of hydrogen. For that, first step will be counting the borane. Boranes are 6. So N equals 6. Hydrogens are 10. So H is 10. There is no charge. So C is 0. So excess of hydrogen will be M. H minus C minus N. H is 10. C is 0. N is 6. If you solve it, you get M equals 4. M4 means it is N plus 4 system. If you look at the table, it is Nido structure. According to the weights rule, C3B3H7 has the Nido structure. Then the next example, here you have NCB10H11. You should find structure of the molecule using weights rule. Here NCB10H11 is given. It is a heteroborane because it is with carbon and nitrogen heteroatom. We should find the boron equivalent. Carbon is 3 plus 1 system, so BH. Nitrogen is 3 plus 2 system, so BH2. So for N, you substitute BH2. For C, you have to substitute BH. Then formula will be BH2, BH, B10H11. If you rewrite it, it will become B12H14. Then the compound becomes simple borane. We should find excess of hydrogen. First step will be identifying the boron. Here 12 borons are there, so N equals 12. Hydrogens are 14, so H equals 14. There are no charges. C equals 0. So excess of hydrogen will be M equals H minus C minus N. H is 14. C is 0. N is 12. If you solve it, you will get M equals 2. So it is a N plus 2 system. If you look at the table, N plus 2 system in Closo structure. So according to the weights rule, the heteroborane NCB10H11 has Closo structure. Then the next example, here you have C2B5H7. You should find structure of the molecule using weights rule. Here C2B5H7 is given. It is a heteroborane with heteroatom carbon. Carbon comes mean it is carborane. So we should write boron equivalent. Carbon is 3 plus 1 system. So BH. So instead of carbon, you should write BH. So the formula will be BH2B5H7. If you rewrite it, it is B7H9. So the compound becomes simple borane. We will find excess of hydrogen. So the first step will be counting boron. There are 7 boron, so N is 7. Hydrogens are 9, so H is 9. There are no charges, so C is 0. Excess of hydrogen formula will be H minus C minus N, which equals 9 minus 7. That gives 2. M is 2 mean it is N plus 2 system. If you look at the table, N plus 2 mean Closo structure. So according to the weights rule, C2B5H7 has Closo structure. Then the next example, here you have Li2C2B10H10. You should find structure of the molecule using weights rule. The real question is whether you count lithium as a heteroatom or not. Here the question is tricky. Lithium salt of carborane is given, so we should take lithium as a cation, the carborane part as an anion. So lithium we don't count as a heteroatom. That is the tricky part of this question. We should take lithium out, bring the charges to the carborane. Carborane is the heteroatom with charge and 2 carbon. We should find the boron equivalent. Carbon is 3 plus 1 system. So boron equivalent will be BH. If you substitute BH in the formula becomes BH2 B10 H10 2 minus. If you rewrite it, it becomes B12 H12 2 minus. The compound becomes simple boron. We can apply the weights rule here. First step will be counting the boron. Here 12 boron, so N equals 12. Then hydrogen, H equals 12. Then charges, which is minus 2. So C is minus 2. So excess of hydrogen will be H minus C minus N. If you substitute the value, it becomes 14 minus of minus 2. 14 minus of minus 2 minus 12 mean M equals 2. So it is a N plus 2 system. If you look at the table, it has Closo structure. So according to the weights rule, Li2, C2, B10, H10 has Closo structure. Then the next example, here you have SB9, H11, sulfur with boranes. You should find the structure of the molecule using weights rule. The given compound is SB9H11. S is heteroatom. We should find the boron equivalent. The sulfur in the oxygen group. It is 3 plus 3 system. So boron equivalent will be BH3. If you substitute BH3 for sulfur, the formula becomes BH3 B9H11. If you rewrite it, you get B10H14. The compound becomes simple boron, so we will find excess of hydrogen. First step will be counting borane, which is N, that equals 10, then hydrogen, that equals 14. There are no charges, so C equals 0. Excess of hydrogen will be M equals H minus C minus N, which gives 14 minus 0 minus 10 gives 4. M4 mean it is N plus 4 system. If you look at the table, it has Nido structure. So according to the weights rule, SB9 H11 has Nido structure. Then the next example, here you have SN9 4 minus. You should find the structure of the molecule using weights rule. Here you have metal cluster SN9 4 minus, which is Zintl salt. To solve the structure, you should write boron equivalent. Tin is in the carbon system, which is 3 plus 1. So boron equivalent will be BH. So instead of tin, you should write BH. So the real formula will be BH9 4 minus. If you rewrite it, it becomes B9H9 4 minus. So the compound becomes simple boron. We can apply the weights rule. For that, first step will be counting the boron. Borons are 9, so N equals 9. Hydrogens are 9, so H is 9. Charge is minus 4. C is minus 4. So the excess of hydrogen will be H minus C minus N. H is 9. If you substitute the values, 9 minus minus 4 minus 9 mean M equals 4. M equals 4 mean it is N plus 4 system. If you look at the table, N plus 4 mean Nido structure. So according to the weights rule, Zintl salt SN9 4 minus has Nido structure. Then the next example, you have BB5 2 minus, which is lead metal cluster. You should find the structure of the molecule using weights rule. Here you have lead cluster. Bb5 2 minus, which is technically a Zintl salt. So we should write boron equivalent to apply the Wade's rule. Boron in the carbon series. So technically 3 plus 1 system. So let this equals BH. If you substitute the BH for lead, the structure will be BH5 2 minus, which equals B5H5 2 minus. Then the compound becomes simple boron. Now we can apply Wade's rule here. For that, first step will be counting the boron, which is 5. So N equals 5. Then hydrogen. Hydrogens are 5. So H is 5. Charge is minus 2. So C is minus 2. So the excess of hydrogen will be H minus C minus N. If you substitute the values, m will be 5 minus of minus 2 minus 5, which gives m equals 2. M equals 2 mean it is n plus 2 system, that is Closo system. So according to the Wade's rule, Bb5 2 minus has Closo structure. Then the next example, B2H7 minus, you should find the structure of the molecule using Wade's rule. Here you have B2H7 minus, it is simple borate, so we can apply the Wade's rule directly. In Wade's rule, you should find excess of hydrogen. For that, first step will be counting the boron. Here number of borons are 2, so N equals 2. Hydrogens are 7, so H equals 7. Charge is minus 1, so C is minus 1. Excess of hydrogen formula will be, so the excess of hydrogen will be 7 minus minus 1 minus 2, which gives 6. So M is 6 mean it is N plus 6 system. By looking at the table, you can see N plus 6 mean it has Arachno structure. So according to the Wade's rule, B2H7 minus has the Arachno structure. Then the next example, it is the interesting one, P4. It is a phosphorus. You should find the structure of the molecule using Wade's rule. Here simple compound P4 is given. It is a cluster called as Zintl salts. We should write boron equivalent to apply the Wade's rule. Here phosphorus is given. It is in the nitrogen series. It is 3 plus 2 structure mean BH2 equivalent. So for phosphorus we should write BH2. So the formula become BH2 4 times. If you rewrite it, it becomes B4H8. The compound becomes simple borane. So we can find excess of hydrogen easily. First step will be counting the boron. There are 4 boron, so N equals 4. Hydrogens are 8, so H equals 8. Charges are 0, so C equals 0. Then the excess of hydrogen will be H minus C minus N, which gives 8 minus 0 minus 4, which gives M equals 4. M is 4 mean it is N plus M is 4 mean it is N plus 4 system. If you look at the table, N plus 4 mean the compound has Nido structure. So according to the Wade's rule, P4 has Nido structure. Then the next example, here you have Ge9 2 minus, it is a germanium cluster. You should find structure of the molecule using Wade's rule. Here germanium metal cluster is given, which is Ge9 2 minus, which is technically Zintl salts. So we should write boron equivalent for germanium. Germanium in the carbon series, which is 3 plus 1 system. So germanium equivalent will be BH. So instead of germanium, you write BH in the formula. So the formula become BH9 times 2 minus. If you expand it, it becomes B9H9 2 minus. So the compound becomes simple boron. So we can apply the weights rule here. First step will be counting the boron. There are 9 borons. So N equals 9. 9 hydrogens are there. So H equals 9. Charge is 2 minus. So C is 2 minus. For the excess of hydrogen, formula is H minus C minus N. If you substitute the values, it will be 9 minus minus 2 minus 9, which gives M equals 2. So the system becomes N plus 2 system. N plus 2 mean according to the weights table, it has Closo structure. So according to the weights rule, GE9 2 minus has Closo structure. Then the next example, here you have INBI3 2 minus indium bismuth cluster. You should find structure of the molecule using weights rule. Here you have indium bismuth cluster. Both are metal cluster. So technically Zintl salts. We should write boron equivalent for both indium and bismuth. Bismuth in the nitrogen group, which is 3 plus 2 system. So bismuth equivalent will be BH2. Indium in the same group of boron. So indium you write boron. So if you substitute both the values in the structure, the formula becomes BH2 thrice 2 minus. If you rewrite it, the structure becomes B4H6 2 minus. The compound becomes simple boron. To identify the structure, we should count number of boron. First step will be counting the boron. There are 4 boron, so N equals 4. There are 6 hydrogen, so H equals 6. Charge is 2 minus, so C equals 2 minus. Excess of hydrogen will be M equals H minus C minus N. If you substitute the values, it becomes 6 minus minus 2 minus 4, which gives M equals 4. M equals 4 means it is N plus 4 system. According to the weights table, N plus 4 mean Nido structure. So according to the weights rule, INBI3 2 minus has the Nido structure. Then the next question. Here you have sp4 2 minus, that is antimony 4 times 2 minus. You should find the structure using the weights rule. The given compound is only with antimony. It is a metal cluster, so it is a Zintl salt. So we should write boron equivalent antimony in the nitrogen group. So it is a 3 plus 2 system. So it is a BH2 system. So instead of antimony, we should write BH2. BH2 4 times 2 minus. If you rewrite it, you have B4H8 2 minus. The compound becomes simple boron. Now we can apply weights rule. First step will be counting the boron. Here 4 borons are there, so N equals 4. Number of hydrogens are 8, H equals 8. Charge is 2, so C is 2. So the excess hydrogen will be H minus C minus N. If you substitute the value, it will be 8 minus of minus 2 minus 4. If you solve it, you will get M equals 6. M equals 6 mean it is N plus 6 system. N plus 6 mean according to the weights rule, sp4 2 minus has the Arachno structure. Then the next example, here you have C2B4H7. You should find the structure of molecule using weights rule. The given compound is C2B4H7, borane with carbon. Technically it's a heteroborane, more specifically carborane. So we should write boron equivalent. Carbon is the hetero atom. it is 3 plus 1 system. So boron equivalent will be BH. So instead of carbon, you should write BH. So the formula become BH2B4H7 minus. If you rewrite it, the structure will be B6H9 minus. Since the compound becomes simple boron, we can apply Wade's rule. First step will be counting the boron. There are 6 boron, so N equals 6. Hydrogens are 9, so H equals 9. Charge is minus 1, so C is minus 1. Excess of hydrogen will be H minus C minus N. If you substitute the values, 9 minus of minus 1 minus 6. If you solve it, you will get M equals 4, that is N plus 4 system. If you look at the table, N plus 4 means it has Nido structure. So according to the Wade's rule, C2B4H7 minus has the Nido structure. Then the next example, here you have SN5 2 minus dianion. You should find structure of the molecule using Wade's rule. The given compound is SN5 2 minus, only tin is there, so it is a metal cluster. It is a Zintl salts, so we should write boron equivalent. Tin is in carbon series, carbon is 3 plus 1 system, so the boron equivalent will be BH. So if you substitute BH for SN, you have BH 5 times 2 minus. If you rewrite it, you have B5H5 2 minus. Since the compound becomes simple borane, you can apply Wade's rule. First step will be counting the boron, which is 5, so N equals 5, then hydrogen, which is 5, so hydrogen is 5, so H is 5, then charges. The compound has minus 2, so C is minus 2. The excess of hydrogen formula is M equals H minus C minus N. If you substitute the values, you have 5 minus of minus 2 minus 5. If you solve it, you have M equals 2. M equals 2 means it is N plus 2 system. By looking at the table, you can clearly see the compound has Closo structure. So according to the Wade's rule, Zintl salt SN5 2 minus has the Closo structure. Then the next example, you have C2B8H10 4 minus. You should find structure of the molecule using Wade's rule. Here given compound is C2B8H10 4 minus, that is borane with heteroatom carbon. So it is a heteroborane. We should write boron equivalent. Carbon is 3 plus 1 system. Boron equivalent will be BH. So if you substitute BH for carbon, you have BH 2 times B8H10 4 minus. If you rewrite, you have B10H12 4 minus. The compound becomes simple borane. So we can apply Wade's rule. To find the structure, first step will be number of boron calculation. Number of boron is 10. Then number of hydrogen, which is 12. First step will be counting the boron. Number of borons are 10, so N equals 10. Number of hydrogens are 12, so H is 12. The compound has 4 minus charge, so C is minus 4. The excess of hydrogen will be H minus C minus N. If you substitute the values, you have 12 minus minus 4 minus 10. If you solve it, you have M equals 6 system. M is 6 means it is N plus 6 system. If you look at the table, N plus 6 means Arachno structure. So according to the Wade's rule, C2B8H10 4 minus has the Arachno structure. Then the next example, here you have SN4 2 minus Zintl salt. You should find structure of the molecule using Wade's rule. The given compound is SN4 2 minus. It is a metal cluster. So technically Zintl salts. So we should write boron equivalent. Tin is in carbon series. So equivalent will be BH. Since it is 3 plus 1 system, BH will be equivalent. So we should write BH for tin. If you write it, you have BH4 2 minus. If you redraw, you have B4H4 2 minus. So the compound becomes simple boron. We can apply the weights rule here. To find the structure, first step will be counting the boron. Total borons are 4, so N equals 4. Hydrogens are 4, so H equals 4. Minus 2 charge is there, so C equals minus 2. The excess of hydrogen is M equals H minus C minus N, which gives 4 minus minus 2 minus 4. If you solve it, you will get M equal to. M equal to mean it is N plus 2 system. If you look at the table, it has Closo structure. So according to the weights rule, Zintl salt SN4 2 minus has the Closo structure. Then the next example, here you have germanium 10 times 2 minus. It is a Zintl salt. You should find structure of the molecule using weights rule. Here you have starting material, which is germanium. Whole structure is made up of only germanium. It is a metal cluster, so it is a Zintl salt. So for the Zintl salt, we should write boron equivalent. Germanium is in carbon series. Boron equivalent will be BH. So instead of germanium, if you write BH, the formula is BH10 2 minus. If you rewrite it, it has B10 H10 2 minus. The compound becomes simple boron. We can apply the weights rule. So first step will be counting the number of boron. There are 10 borons, so N equals 10. Total number of hydrogen 10, so H is 10. Number of charges minus 2, so C is minus 2. Then excess of hydrogen will be M equals H minus C minus N. If you substitute the values, H is 10, 10 minus minus 2 minus 10. If you solve it, you have M equals 2. M equals 2 mean it is N plus 2 system. If you look at the table, the compound has Closo structure. So according to the weights rule, the Zintl salt Ge10 2 minus has the Closo structure. Then the next example, here you have sp7 3 minus, that is antimony 7 times trianion. It is a Zintl salt. You should find structure of the molecule using weights rule. The compound is only made up of antimony 7 times with 3 minus. So it is a Zintl salt. For Zintl salt, you should write boron equivalent. Antimony equals to BH2. Since it is the nitrogen group compound, it is 3 plus 2 system. So BH2. So instead of antimony, if you write BH2, the formula becomes BH2 7 times 3 minus. If you rewrite it, you have B7 H14 3 minus. The compound becomes simple borane, so we can apply the weights rule. First step will be counting the boron. There are 7 boron, so N equals 7. Hydrogens are 14, so H is 14. Charge is minus 2, so C is minus 2. If you find excess of hydrogen, which is H minus C minus N, if you substitute the values 14 minus minus 3 minus 7. If you solve it, you get M equals 10. M equals 10 mean it is N plus 10 system. If you see the table, it has clado structure. So according to the weights rule, Zintl salt sp7 3 minus has the clado structure. Then the next example, you have Bb2 sp2 whole charge is 2 minus. it is tin antimony metal cluster. You should find structure of the molecule using Wade's rule. The question is tricky and interesting because the whole structure is made up of two metals, which is lead and antimony, which is technically Zintl salt. For Zintl salt, we have to write boron equivalent. The lead is in carbon group, so equivalent is pH. The antimony in nitrogen group, so boron equivalent will be pH2. If you substitute the boron equivalent in the compound, you have BH2 twice 2 minus. If you redraw nicely, you have B4H6 2 minus. The compound becomes simple boron, so we can apply the Wade's rule. First step will be counting the boron. Borons are 4, so N equals 4. Number of hydrogens are 6, so H equals 6. Charge is minus 2, so C is minus 2. Excess of hydrogen will be H minus C minus N. If you substitute the values, it is 6 minus minus 2 minus 4. If you solve it, M equals 4. M equals 4 mean it is N plus 4 system. If you look at the table, N plus 4 system mean Nido structure. So according to the Wade's rule, the Zintl salt Bb2 sp2 2 minus has the Nido structure. Then the next question, the given compound is SN2Bi2 2 minus, that is tin and bismuth metal cluster. You should find structure of the molecule using Wade's rule. Here given compound is SN2Bi2 2 minus. It is a bimetallic cluster, technically Zintl salts. So we should write boron equivalent. Tin is in carbon group. Boron equivalent will be BH. Bismuth is in nitrogen group. Boron equivalent will be BH2. So if you substitute the boron equivalent, the structure will be BH2. BH2 twice 2 minus. If you rewrite it, it will be B4H6 2 minus. The compound becomes simple boron. So we can apply the Wade's rule. First step will be counting the boron. There are 4 boron, so N equals 4 and 6 hydrogen, so H equals 6. Charge is minus 2, so C is minus 2. So the excess of hydrogen will be H minus C minus N. If you substitute the values, 6 minus minus of minus 2 minus 4. If you solve it, you will get M equals 4. That will give N plus 4 system. If you see N plus 4 mean Nido structure. So according to the Wade's rule, SN2Bi2 2 minus, the Zintl salt, has the Nido structure. Then the next example. Here you have AS7 3 minus, that is arsenic cluster. You should find structure of the molecule using the Wade's rule. Here you have metal cluster only with arsenic. So technically it is a Zintl salt. Arsenic is in the nitrogen group. So the equivalent will be BH2 because it is a 3 plus 2 system. So if you substitute the boron equivalent, the structure will be BH2 7 times 3 minus. If you rewrite it, you have B7 H7 3 minus. The compound becomes simple boron. So you apply the Wade's rule. First step will be counting the boron. There are 7 boron. So N equals 7. Hydrogens are 14. So H equals 14. Charge is minus 3. So C is minus 3. So the excess of hydrogen will be H minus C minus N. If you substitute the values, 14 minus minus 3 minus 7. If you solve it, you have M equal 10. M equal 10 mean it is N plus 10 system. According to the table, the compound has clado structure. So using the Wade's rule, If you find the structure of the Zintl salt AS7 3-, it has clado structure. Then the next example, here you have C2B10H12. You should find structure of the molecule using Wade's rule. Here given compound is heteroborane, borane with carbon. We should write boron equivalent. Carbon is 3 plus 1 system. So equivalent of boron will be BH. If you substitute the BH for carbon, you have BH twice B10H12. If you rewrite it, you have B12H14. The compound becomes simple borane. So you can apply the Wade's rule. First step will be counting the boron. There are 12 boron. So N equals 12. 14 hydrogen. So H is 14. Charge is not there. So C is 0. So if you find excess of hydrogen, M equals H minus C minus N. If you substitute the values, you have M equals 14 minus 0 minus 12. If you solve it, you have M equal 2. M equals 2 mean it is N plus 2 system. According to the table, it has Closo structure. According to the Wade's rule, the heteroborane C2B10H12 has the Closo structure. Then the next example, here tellurium 4 times 2 plus is given. It is a tellurium cationic cluster. You should find structure of the molecule using Wade's rule. The given compound only made with tellurium, so it is a metal cluster with cation. Technically Zintl salt. So we should write equivalent for tellurium. Tellurium in the oxygen group. So the equivalent will be BH3. If you substitute BH3 for tellurium, you have BH3 4 times dication. If you rewrite it, you have B4H12 2 plus. So the compound becomes simple boron. You can apply the Wade's rule. First step will be counting the boron. Number of borons are 4. So N equals 4. Number of hydrogens are 12. So H is 12. Charge is plus 2. So if you find excess of hydrogen, which is H minus C minus N, if you substitute the values, it is 12 minus plus 2 minus 4. If you solve it, you have M equals 6. M equals 6 mean it is N plus 6 system. If you look at the table, N plus 6 mean Arachno structure. So according to the Wade's rule, Zintl salt Te4 2 plus has the Arachno structure. Then the next example, here you have SN5 sp3 3-, that is tin and antimony metal cluster. You should find structure of the molecule using Wade's rule. Here SN5 sp3 3- is given. It is a metal cluster. Technically Zintl salts. So we should write boron equivalents to identify the structure. Tin is in carbon series. So the boron equivalent will be BH. Antimony in the nitrogen series. So the boron equivalent will be BH2. If you substitute the values in the metal cluster, the formula will be BH 5 times, BH2 3 times, 3-. If you rewrite it, you have B8H11 3-. So the compound becomes simple boron. We can apply the Wade's rule here. First step will be counting the boron. Number of borons are 8. So N equals 8. Number of hydrogens are 11. So H equals 11. Charge is minus 3. So C is minus 3. So the excess of hydrogen will be H minus C minus N. If you substitute the value, it is 11 minus of minus 3 minus 8. If you solve it, you have M equals 6. M equals 6 mean it is N plus 6 system. If you look at the table, n plus 6 mean Arachno structure. So according to the weights rule, the Zintl salt SN5 sp3 3 minus has the Arachno structure. Then the final example, Bi4 2 minus, it is the bismuth cluster. You should find structure of the molecule using weights rule. Here bismuth 4 times 2 minus is given. It is a metal cluster, technically Zintl salt. So we should write boron equivalent. Bismuth is in nitrogen series. So the boron equivalent will be BH2. If you substitute BH2 for Bi, you have BH2 4 times 2 minus. If you rewrite it, you have B4H8 2 minus. So the compound becomes simple borane. You can apply the weights rule. First step will be counting the boron. There are 4 boron. So N equals 4, 8 hydrogen. So H equals 8. Charge is minus 2. So C equals minus 2. So the excess of hydrogen will be H minus C minus N. So M equals 8 minus of minus 2 minus 4. If you solve it, you have M equals 6. M equals 6 mean it is N plus 6 system. N plus 6 mean if you look at the table, it has Arachno structure. So according to the weights rule, the Zintl salt Bi4 2 minus has the Arachno structure. Then we summarize what we learned already. To identify the structure, first step will be finding the excess of hydrogen. The formula is M equals H minus C minus N. H is number of hydrogen, C is charge, N is number of boron. If Zintl salt and heteroborane is given, you should write boron equivalent. Boron group mean boron, carbon group mean BH, nitrogen group mean BH2, oxygen group mean BH3. Once you find N plus M, if it is N plus 2, the structure is Closo, N plus 4, Nido, N plus 6, Arachno, N plus 8, Hypho, N plus 10, Clado, N plus 0, Super Closo, N minus 2, Hyper Closo. So you should master both the tables to identify the types. More importantly, there are so many examples. So you should solve yourself, understand the problem better.